You can go ahead,
Good
Anthony.
morning. Good morning. My name is Anthony Matenko, and on behalf of the Horticulture School Planning Committee, I would like to welcome you to the first of two webinars on high tunnels in Manitoba in our 2025 spring webinar series. Today's webinar is entitled High Tunnel Design and Construction, is presented by Tom Gonzalez. If you have any questions that you would like to ask Tom during the presentation, please enter them into the chat feature on your screen, and Tom will be able to answer your questions at the end of the webinar. Tom Gonzalez is the provincial vegetable fruit vegetable crop specialist with Manitoba Agriculture based in Carman and has been with the department since 2005. Tom has experience in working with both the vegetable and potato industries in various capacities over the past 40 plus years. He works with Manitoba vegetable producers in the industry on improving vegetable production via extension and research projects aimed at increasing the yield and quality of vegetable crops grown in the province. Tom was nominated for the Manitoba Government Service Excellent Team Award and is the lead for the horticulture school events such as this webinar and in-person field days and meetings. Take it away, Tom.
Thanks, Anthony. So, as Anthony said, today's webinar is entitled High Tunnel Design and Construction. And what I'm going to be talking about includes we'll discuss what a high tunnel actually is. We'll talk about design and construction details of the high tunnel that we built. And then I'll do a bit of a summary. And along the way, if any questions arise, type them into the chat and we can get to them at the end of the presentation. So I think we want to talk a bit about what a high tunnel actually is. So there's a number of different terms that can be used for a high tunnel. Hoop house, non-conventional greenhouse, things like that. But the most common term is a high tunnel, and it's loosely defined as a non-permanent structure. It won't have a foundation or a permanent heat source, and it's covered with greenhouse poly. The type of framing, it's usually tube aluminum, but I mean, the type of framing varies. It could be anything from wood to tube steel or the more common tube aluminum. To remove excess heat or retain heat, you do that by opening and closing of vents or rolling the sides up and down manually. Like they're in a greenhouse, you'd have automatic vents with fans that could exhaust heat out or close and to retain heat. And none of those features would be in a standard high tunnel. It's just going to be passive venting to let heat out or close everything up and keep heat in. I want to be clear that a high tunnel is not a year-round production system. It just wouldn't be a viable way to grow vegetables or fruit crops, any crop really, in Manitoba year-round. Um, but a high tunnel will extend the growing season. You're basically going to be able to start a little earlier and go a little later than you would if you were planting crops in the field. So on the shoulder of the seasons, let's say you're going to get in earlier in the spring and stay harvesting later into the fall. Um, in a high tunnel, it's common. The most common way of planting is having crops directly planted into the soil. But that's not to say that all crops are planted directly into the soil. Sometimes, under different circumstances, their containers are used, and those containers can vary in size, shape, and that. There'll be a bit of a discussion regarding that in the next webinar of this series. Uh, Crops, how can I say this? So you would get frost protection from a high tunnel, and basically the the plastic is going to give you, we've seen 3 to 5 degrees Celsius of frost protection inside the high tunnel. In some cases, though, producers want to have an added layer of frost protection. So you could use additional coverage of your plants inside the high tunnel with plastic, like a low tunnel, for example, where over the rows in the tunnel, you would run a second or additional layer of poly on top of that to protect against frost. There's going to be a labor component to install that and uninstall it as the temperatures warm up, and the cost of getting the pulley and the hoops for the low tunnel. But you can have more frost protection than just the high tunnel gives if you're willing to pay for it. Now, I'm not going to show this video, but there is an excellent video from Pennsylvania State University that will describe to you what a high tunnel is. The link's on your screen. I know that can be awkward to access, but if you Google Pennsylvania State, what is a high tunnel video, it would be in the top two hits that you'd get on your Google search. And it's only a 5 minute video, but it's very informative, and I encourage you to take the time to go over there and have a look. So here, this is a picture off the Haygrove website. Haygrove is a supplier of high tunnels, and we're just going to show. I'm just going to show a couple pictures that we'll talk about a bit. Now here, I want you to take note that at the end here, there is some plastic hanging down over there, but there's not a true end wall in this specific high tunnel. The other thing to note, the arches are anchored at the ground level, running on both the left and right side, and there is a center rib running down the midpoint of the high tunnel, holding the arches together. And that's one type of high tunnel that Haygrove would sell. Now, here, this is off a different supplier's website. It's not that one high tunnel design is better than another necessarily, but what I want you to look at here is this end wall. Excuse me. It's basically sealed up with plastic in this design. Plus, the arches are attached at ground level. Plus, there's one, two, three, four, five, six additional ribs. So you've got 8 points of attachment holding those ribs together, and there's some dimensional lumber. So really 10 points of attachment holding those ribs together. So this specific high tunnel is going to be significantly stronger when it comes to engineering than the previous one. Now, I guess I'm not trying to say one brand is better than another, because within each brand of high tunnel, you can find higher end and lower end option tunnels for sale. So it's not necessarily any one brand of tunnel is better than another. They're just different. Now, here's a shot of our high tunnel. This was, I think, last fall or the fall before. Um, we'll go into more detail about the high tunnel we built, but that's just a outside shot of it in Portage la Prairie. Now, when it comes to design and construction, I think it's important to know that basically you can go online and search out high tunnel suppliers, manufacturers. You can get prefab kits, can find prices and have them specced out with what you would like to have. Um, Most of the kits are bought as a do-it-yourself in the sense of assembly. You would get the material for the arches, the poly, uh, everything you would need to build the tunnel would arrive on your site. But You can also, most places, you can have, if you're willing to pay for it, you can have it built for you. Um, Obviously at additional cost, I mean, but most people would assemble the kit themselves. Now, there are a number of manufacturers and dealers for high tunnels. Haygrove, Farm Tech, Grossman, they're ones that have been around for a while. I'm not saying any one is better than another. Winkler Structures is a local Manitoba company. They were making bale sheds and temporary structures out of tube aluminum framing for quite a while. And so they branched into also having high tunnels, the same structures, they just covered with a greenhouse style poly. But I think the thing here is you'd want to search high tunnel sites, look for the options that you want for your specific location, do some pricing, and see what works for you. So the internet can be your friend in this case. The majority of kits that are out there are made with tube aluminum framing, and the diameter of those aluminum tubes will vary. Obviously, the wider the diameter tubing, the more expensive it's going to be, but the stronger it will be. So just be aware that not all kits are created equal, I guess. Do your research. It's important. So I just put a few screenshots on here of some websites that deal in high tunnels. So here is Haygrove's website. You could navigate through their Farm Tech website, the Growspan website, and Winkler Structures website. I think the key would be to compare prices, compare features, uh, any currency exchange, shipping charges. You know, got to factor everything in to the final cost. But like I said earlier, the internet can be your friend in this case. Just do your research and due diligence. Um, when you're trying to decide what you'd like, what features you'd like to have, there's a great fact sheet from the University of Minnesota. And again, you could get to it via the link on the screen, or if you Google searched University of Minnesota choosing a high tunnel, it would be within the top three hits on your Google search. And I think it's about an 8-page document or so. It goes through some of the pros and cons of different types of tunnels, uh, and it's really good to look at. So I would recommend anyone looking to get into high tunnels should go to that document and have a look, see what would work best on your farm. Now, there's many different grades of high tunnel. Well, at least two main grades, commercial and residential, and some in between. Probably the most common is going to be commercial grade. It would have generally heavier duty materials going into it than a residential high tunnel would. But again, you just have to check the specs when you're searching online. Don't assume anything. Make sure you've found out specifically what grades of materials go into your high or go into the high tunnels when you're searching for them. Now, residential size high tunnels are usually going to be smaller than commercial high tunnels. Residential high tunnels, I've seen as small as sort of 10, 12 feet wide and 20 feet long. That's kind of a garage, basically. You know, it's not very big in the sense of a structure. Commercial tunnels, boy, they can be up to 30 feet wide and a couple of 100 feet long. Plus, they can be linked together and have five, six, seven, maybe even eight tied together kind of thing. So huge area of production. Um, Now, we've kind of alluded to this that prices are going to vary based on the quality of the parts and the options that are in there for the high tunnel and whether there's going to be a labor cost charged to you to assemble the high tunnel on your site. So just be aware when you're searching to compare apples to apples in a sense. If you don't want to build it yourself and you want it assembled when it's on your site, make sure that cost is included in each of the quotes. Um, so let's say you couldn't find a high tunnel that did everything for you that you wanted, didn't have the features that you decided were best for your operation. So an option then would be to design and source the parts to put together your own high tunnel. And when we were looking to put together our high tunnel, we had requirements that didn't seem to be met. At least we felt they weren't met by the kits that were readily available at the time online. So we went out and decided to basically design and create our high tunnel to suit our needs. We weren't necessarily just doing it for the good of our health. We just needed stuff we figured was important to have. Features just weren't available, so we decided to do our own. And the primary feature that we wanted to have, we wanted the tunnel to last, the frame to last. Um, Most tunnels are tube aluminum. Tube aluminum is a excellent building material. I'm not trying to say it's terrible. Obviously, the thicker the tubing, the stronger it is. But snow load can be your enemy when it comes to high tunnels, in particular those with tube aluminum. In in the US, for example, where high tunnels are fairly common around large metro areas, most high tunnels will have in their budget built in a 4 to 5 year lifespan, not for the poly, but for the high tunnel itself, just because they're finding they don't last. Sometimes they will last longer, but they're finding for them to be profitable, they're figuring on replacing it every 4 to 5 years. Not to go too deep into the weeds, but if you've ever been involved in trying to procure things when you're in government, it can be very laborious and time consuming. And we did not want to have to go back after 4 or 5 years because the frame of the tunnel collapsed in the winter under snow or something to get another tunnel. So we wanted a tubular steel frame, and we wanted a slightly narrower tunnel than most just because of the space we wanted. It turned out ours was 15, turned out to be 15 and a half feet wide, but we could have lived with a little more, a little wider or a little narrower, but we went with 15 and a half feet. Now, we developed a fact sheet that's on the Manitoba Agriculture vegetable crop page that goes into what we're discussing today. And again, that can you can access that from this link. But the other way to do it, if you searched Manitoba agriculture, vegetable crops, high tunnel, you'd get with again within the top two or three search hits, you would get this fact sheet, this PDF document, and basically it just goes into a little bit of detail describing how the design and setup of the high tunnel that I'll be telling you about today went. So it'll just be another reference to for you to use. So that's available online. Now, let's get into some of the details here. So basically, we wanted to have a 2x6, shall we say, as a ledger board running underneath the arches. So the arches were made out of 24-foot lengths of tubular 1-inch steel, bent, and had a 1 inch, or sorry, a half-inch steel plate welded onto the bottom of each arch, and then that plate is screwed onto a 2x6 ledger board. But we didn't feel comfortable in just putting that 2x6 on the resting it on the ground. So, because this was just a field that had been worked the fall before. So what I did is we took a tractor, fairly heavy tractor, I think it was around 120 horsepower or so, and I just drove back and forth with the tractor wheel going along where the 2x6 will be laying on the ground and made a wheel rut. Then with a bobcat, took some soil and filled that rut in and then drove on top of it again. 3 or 4 or 5 times, packed it down, used the bobcat, put some more soil on there, packed it down. We repeated that process 3 or 4 times to where we at least packed that soil somewhat. It's not a foundation. It's not like we could pour concrete on top of that and have it stay level, but at least it did pack it a bit. And then that's what we used to, or sorry, where we laid our 2x6 down. Um, well, here, just describing what I just told you here. So the treated lumber is going to sit on the surface of the soil, and the steel arches are bolted to that or screwed to that. Sorry. So here is a picture of one of our summer students when we were building the frame for the tunnel, and you can see here that she is screwing that half-inch steel plate onto a 2x6 that will hold that side of the arch. Now I'm just going to zoom in here a bit. Um, Okay, so here's the plate that she's working with. The other thing I want you to take note of is we wanted it to be 15 and a half feet wide, and generally that was the diameter or the length, sorry, at the bottom of the arch. But we just made a jig, a couple of 2x6s screwed together that we had laying around that we were using for 15 and a half feet. So it just sits there. You don't have to measure every time. The other place we use the jig is between the arches. Oh, here's a closer one. So right in front of us here, right at the bottom, there's a dimensional piece of lumber sitting here that is 47 inches wide. Our arches are the, the material used to make the arch is an inch in diameter. So basically, we wanted 48 inch on center. So this piece of wood is 47 inches long. So you'd put it between the arches. Again, that just saves measuring every time. You don't have to worry about having a tape with you all the time. So using a jig can help you out. Um, okay, the steel arches are attached at the top using treated lumber. You remember in some of the photos I was showing you of high tunnel kits, it had a mid rib running down. It was usually tube aluminum that was used. We had toyed with the idea of using tubular steel for that. The only issue that stopped us from doing that, though, is obviously steel isn't very forgiving. We would need to have everything perfectly level and square and plumb if we're going to pre-drill our holes through steel and have them line up. So we chose to go a little easier route where we put cut pieces of 2x4 up there, attach them with a vice grip to the steel plate, and then drilled through the steel plate or through the steel plate into the 2x4 and bolted it that way. So it just made it easier to work with wood than steel. Now, you can see here, this is just another shot of the high tunnel as we're putting it together. The jigs that we used are laid out here again. Uh, I'll get into a little bit later what these ratchet straps are being used for, but it's just another shot of the tunnel as it's being erected. Now here we'll give you a little bit of an idea again of how we put this mid rib on there. So I think I'm going to zoom in again. Give me a second here. Okay, so what you can see here is the piece of dimensional lumber that Anthony is holding here is our jig that's going to keep the arches at the exact distance we want apart. So they'll be on 4 foot centers. And right in here is a vice grip. It's not your standard vice grip. It's got the bigger, wider jaws on it. So what we'd do is we'd set the arch to the right distance apart with the jig, clamp that vice grip down onto the steel plate there. And so the 2x4 is held to the steel plate. Then we drill through the pre-made hole in the steel through the wood, and that would allow the bolts to go in. So you can see over here on the right-hand side, 4 bolts. Those holes need to be drilled into here, and then you put the bolts in. It's really quite simple, and it made it significantly easier for us to work with, less of a pain, to be honest, than if we were trying that with steel. So it worked out pretty well using that system. Um, Now, remember I was talking to you about the ratchet straps. So one of the concerns in this design, because some of the designs of the tunnel will actually pound the arches into the ground to hold it. This is just sitting on the ground on this ledger board. So we still needed to hold this down to the ground. So what we did, I'm gonna zoom in here again. Give me a second. Okay. So right here, you can see there's a piece of rebar. It's cut fairly long. It is, I believe, 4 feet long, and there is a chain link welded onto the side there where one end of the ratchet strap is hooked into, and that rebar is pounded into the ground. About 85% of the length is pounded into the ground at a bit of an angle to the side. Then on the high tunnel, you can see here on the arch, there is a chain link welded on here where the other end of the ratchet strap is on. So basically, you have the two ends of the ratchet strap, one on the arch and one on this rebar peg. And then you just articulate, or not articulate, you just ratchet the ratchet strap and tighten it down to hold it down. And we put those ratchet straps every 8 feet. Every second arch had a ratchet strap going along the tunnel. So that was how we chose to hold our tunnel down because we did not physically pound the arches into the ground. You could do it either way, but this just worked for us. Um, when it comes to the greenhouse poly, we used 11 mil greenhouse poly, fiberglass reinforced. Worked real well for us, but we're covering an area that's 100 feet long and is the circumference of the arch is over 24 feet basically. So you need additional poly to work with. So we went with 120 feet wide or 120 feet long and 28 or maybe 30. I can't remember exactly how wide we were. Uh, but basically, you want the day to be very calm and have a lot of hands available when you're putting it up. You don't want that thing to be a sail. It'll wind up in the bush and then it's going to get torn up and it just wouldn't be good. So just remember more hands, more people. It's going to be better. I can't stress that enough. When we did our poly installation. Boy, I brought people in for 7 o'clock, plied them with coffee and donuts, and it was not as, it was more windy than the forecast was for that day. And we basically, I had to pull the trigger and say, no, we're not going to try it. We'll wait for a more calm morning. And they still got their coffee and donuts, mind you. But anyway, I'm just saying, don't rush doing the poly thinking, oh, I got to put it on. It would just be a mess if it got away from you. So here's a shot of poly when it's not attached yet. It's just stretched over the high tunnel, and we're going to be managing to install it. One of the one of the ways that, or the, sorry, a standard way that greenhouse poly is installed is using wiggle wire. I'm not sure how many of you are familiar with wiggle wire, but it is a fairly common practice and an industry accepted standard. We chose to use a made in Manitoba fastener system that it's not as common. It's a little bit cheaper, not a lot cheaper, but we wanted to see how it would work, and it has worked. It's worked excellently. So the way it works, this top photo here is, well, let's say right here, it has a flat piece of plastic with a rib sticking out of it, and that rib reinforces this piece of poly, or sorry, piece of plastic here. And the piece of plastic gets fit in to this channel here. You basically push it up and under right here. I'm going to zoom in a bit here. Okay, so you take that piece I was showing you above and you push it under here with the poly between the two pieces. So basically, the poly comes over top of this channel. Then you take that fastener and you shove it inside, up in there. Then the bottom piece, or sorry, the bottom edge will just plop down into there, and the pressure of the poly just holds it in there. It, if the wind gets up and starts to put pressure on the poly, it actually tightens this fastener. It doesn't loosen it. It's an excellent system. I would I would recommend it. You don't have to be using it, but it is a very good system. It worked for us for over 10 years now, and we've never had to replace it. So it's been very good for us. Um, Now, how do you install that? Well, you can see again, it takes a lot of hands. So what we're doing here is some people are pulling the poly taut over the arches. I have what looks like a pizza cutter in my hand here. It's basically a roller, but it doesn't have an edge on it. It's flat. So remember, the piece that slips in under there has that rib sitting up on it. So the pizza cutter you take right here and you roll it down this edge here as you're pushing upwards, and that snaps into the channel that is screwed onto the tunnel. So again, you need a fair number of hands when you're doing this, and but it's an excellent system to hold it on, and I would say it's as good or better than wiggle wire personally. Uh, Now, one thing it should be noted with the poly that we got, like I say, 11 mil fiberglass reinforced greenhouse poly, it came with a 2-year warranty. And basically, this past season was its 10th anniversary. So happy 10th anniversary to our poly. Uh, just know that 10 years we've seen is pretty much the max. There are holes appearing where the poly has basically rotted between the fiberglass strands. We don't have any big tears in it, but there's spots where the poly Whether the UV coating has disappeared on it, I don't know, but it rotted. But it still is solid on there in the sense there's no tears. But before we use it again, we're going to have to replace the poly. But we did get 10 years of service in Manitoba from a product that had a 2-year warranty. So I would say we did pretty well on that. One thing we haven't discussed in our design is the end walls. To be honest, when we were doing this, we didn't know ourselves what was going to be the best way to do end walls. We tried some some ways, and it didn't work out. And then we basically stumbled onto a way that worked for us. So we used treated.
It seems like Tom has frozen. Aaron, are you getting the same results?
So on here, this is held on by the bolt to a piece of flat iron behind there. There's another piece down here, slightly hidden by this ratchet strap. And then we have dimensional lumber, 2x4, to create some studs, for lack of a better word, that sit down here on a plate that is on the ground. The plate is held to the ground by some bent rebar that's just pounded in the ground to hold it there. And that's how we created our end wall, or at least the sides of our end walls. Now, just going to slip over to this other side here. So this happens to be from last year. So this is after 10 years of use. But a couple of things I wanted to show are the doors. That's We didn't have the doors on that first year. So the doors we made out of dimensional lumber. They have a venting half to them, basically a hinged window there with a gas operated sensor that when the temperature warms up, the gas expands and the piston is moved and this will open. It's not, you can't fine tune it all that well, but it does work. And again, it gives you some flexibility in heat control. And the doors, basically, we just built them out of 2x4. And I don't know if any of you have ever made your own doors or whatever, but they're going to sag over time. So to deal with that, we put gussets on the corner here that are screwed to the frame. But the main thing is there's some wire uh, with a turnbuckle in the middle here that can be adjusted to lift the edge of the door as it sags over time. Because you just know it is going to sag. I may not be the worst carpenter in the world, but I don't care who you are. If you're building something like this, it is going to sag over time. So basically, that's how we built the door and how we did our automatic, if you want to call it that, ventilation system. Now, a manual way of venting is our gable vent here. So the gable vent is above the door. You can see there's a piece of wood, happens to be painted yellow, but there's a piece of wood that's holding the gable door open. It's very manual, this. It's not automated, but it does allow for venting of heat and entrance of cool air too. Um, Moving on the outside, this is a view from outside the tunnel. It shows the main way of ventilation. You can see is the doors are open here. The gable vent is open here, but the sides, you've got 100-foot long sides here that they're rolled up 3.5, 4 feet kind of thing. So your square footage, the place where you get the most square footage of ventilation is on the sides. The doors are about seven, no, 6.5 by 6.5, say, whereas the sides are 100 by 4, and there's two sides. Well, there's two doors as well, but you're going to get most ventilation through your sides. Now, one question that comes up, costs. I mean, that drives business. So our cost in 2014 dollars, because that's when we built our tunnel, would have been just over $5,200 for the design that we had come up with. A kit at the time that would be comparable. It would be a little bit larger though, be 100 feet by 20 feet. So you'd be getting a little more width in there, is a little over 11,000. Now, we did want, you see, I put it in quotes there, some extras. We wanted to have some auto ventilation features. We wanted irrigation, things that don't come in your standard high tunnel kit. So for us in there, the total, excuse me, was just over 7,100 to taxes in and our extras that we felt we needed. So again, relative to the cost of a kit, it was significantly lower. Okay, so I've talked for way longer than I thought I would, but in summary, high tunnels will create a longer growing season for crops. Let's take away that from this discussion. High tunnel kits are available to purchase. Search online, do some shopping, compare features. You can you can go online and get prices. You could also build a custom high tunnel from scratch if you couldn't find kits that provided you what you wanted to have in the way of needs and requirements, or sorry, fit your needs and requirements. Okay, that's basically what I wanted to say. I'm not sure if we have any questions or not in the chat, Anthony, but if there are, I'm more than willing to take them.
Thank you, Tom. Yeah, as Tom said, if you have any questions, please type them in the chat feature. We do have a two-parter question. Um, from a durability perspective, how do you think design of your high tunnel compares to tunnels from prefab kits?
Okay, so for longevity, I think the standard first, let me say the standard poly that you're going to get in your basic high tunnel kit is 6 mil, non-fiberglass reinforced. We had 11 mil fiberglass reinforced. The standard you're going to get in the kits for tubing to or for arches is going to be aluminum tubing. It's going to be probably not 2 inches. It's going to be 1 inch to inch and a half tubing. We had 1 inch steel tubing that made our kits. I'm going to say the longevity would be greater for a high tunnel built the way we built it as opposed to from a kit. That's not to say that from a kit it's no good. That's not what I'm saying, but I'd say it's more durable. I hope that answers the question.
Yeah, and if I could just add into that, that tunnel, summer and winter, has gone through some incredible windstorms, plus 100K winds.
Yeah.
And we've haven't, there's been no problem. Even at its advanced age now,
Yeah.
um, it's still solid.
I think
And
too, did
yeah,
we
go ahead.
not? Sorry, Anthony, did we not have a hailstorm the one time? It wasn't the worst in the yard where the high tunnel is, but if I remember right, I think we had about 10 minutes of some pretty decent hail that one year.
Yeah, yeah, that was that definitely held through that as well. So just second part, is there anything you do differently if you were to build another high tunnel?
Yes. Okay. I'm just gonna go back here a bit. I'm not sure how far I gotta go. Oh, not too far. Okay. So on my screen here, you can see there's a 2x6 uh, length of lumber down the sides of the tunnel.
Yeah.
The original plan for venting was to not have the full length of the tunnel used for venting, but frame in some windows, for lack of a better word. And that's why this piece of lumber is here. So we could use it to attach uh, frames for windows or window vents to. Now, because that isn't what we chose to do in the long run, I would just remove this length of 2x6. Um, what else would I do? Not a whole lot, really. I mean, the design has been pretty good. No, I would say that would be the main thing.
Okay, cool. So we got a couple more, actually, about quite a few couple questions here. Okay, so I'll just go through the list. From
Sure.
a labor perspective, do the kits also require many people on hand to erect, or are they designed in a way that's not as important?
Okay. Again, I think there's going to be some variability from different manufacturers, but from what I've seen and what I've heard from folks who have brought kits in, you will need a number of people. By that, I would say 3 to 4 to make the erection of the structure easier. But again, if you're doing the poly and it's not a what I would call a small tunnel, like if it's 100 feet long, holy smokes, I would want a minimum of 5 or 6 people down each side to be able to hold it, and I'd want calm weather. But you could get away with to just put up the frame itself, you could get away with 2 or 3 probably. I mean, you'd be climbing ladders more often. The more people you have, the easier it is in time. But yeah, you could probably get away with 2 or 3.
Okay. Um, Another question, do you know if the US government still funds high tunnels as they did at one time?
Well, not to be political, but I think there's been cuts in the U.S. Government, federal government system in the last couple of weeks that no one really knows how they're going to shake out. But before that, they had funding available for construction of high tunnels that, or sorry, through programs that would supply funding annually when you produced a crop in there. And that funding, from what I'm told, I've never went to their website to search it out, but from people in the States, fellow researchers and that I've spoken with, those funds would pay the capital cost of the high tunnel off in 3 to 4 years, kind of thing. So that's a pr pretty good payment if you think in a business plan that you don't have to account for your revenue to pay your capital costs. You're only going to have to be paying your fixed, or sorry, your other fixed costs and your variable costs, but not your capital costs to build your tunnel. That's significant. But again, I can't say if that program is still going on after what we're hearing about all the cuts to U.S. federal programming.
Yeah. Okay, so the prices you showed for the high tunnel were for 2014. What would be today? What do you think a comparable design cost would be now?
Oh, Lord.
Well, for kits, I would say we're probably more in the closer to 20,000 range now.
Yeah, I was gonna say, and it's just a guess, but I'd double the costs that were shown there.
Like for our
For
made in
our
Manitoba
tunnel, for
design.
kits, just in general, it may be a little less, like it might be 80% or something like that. But cowboy math, easy in your head. If you double everything across the board, I think you're going to be close. You might be a little high, but you're not going to be ridiculously high.
Yeah. Um, in your design, is there a mechanism to roll up sides, or is it that a tricky manual operation every time?
Sounds like a question that you or I would be asking, Anthony.
Well,
Okay.
I would say, okay, I forget you described how you we did the sides, right?
No, I didn't physically, but I will right now. Can I
Because
take a
it's
second here?
yeah, yeah,
Okay, so here's zoomed in on a picture of one end of the high tunnel. Now you can see here there is a plastic T handle here, and you can't tell, but it's hollow. It's made out of plastic piping and fittings. And this is a piece of rebar that we just shove through the tunnel into the dirt to hold it up. Very low tech, but it works. So now, just gonna move this picture a bit. So this handle is attached to an uh, aluminum
galvan,
pipe.
gal from like
Galvanized, sorry,
yeah,
my bad. It's a galvanized top rail to a chain link fence. And they came in, I think, 10-foot sections. One end is a male end of the pipe, one end is a female, so they fit together. And what we did is we put them down to 100-foot length, cut off the excess, and at the joints, we used self-tapping screws to hold them together. So basically, when you roll at one end, and I should say at each end, we have a T handle, exactly the same at each end. So this operation takes two people. So if the sides are up right now, you would, with your body weight, hold that T handle where it's sitting, remove the rebar that's in there, and then you have to gradually let it go down because if you just release that, gravity and the weight of it is just going to plummet to the ground. So you have to be prepared to be holding on. I would suggest wearing gloves and just going slowly. And the two people need to be a bit coordinated together in how they do this. We have done it, or I should say, I have done it with one person, where at one end I've put a couple of hay bales but to make it half the height of the opening. And I've undid one end and lowered it down, rested it on the hay bale, walked to the other end, undid that end, rolled it down to the ground, gone back to the other end, removed the hay bale, and lowered it down. So it can be done with one person, but it's much easier with two people.
and it's not like we came up with this ourselves. We're not that smart. We the Nobel Foundation in Oklahoma actually had some plans for a high tunnel design, and they had this feature on their high tunnel, and we go, well, they're doing it because you would think over 100 feet, how's this going to work? But it actually
Mm.
works really slick.
Yeah.
And there are, I know for kits, there are uh, mechanical side, uh, like motors that roll up the
Yep.
sides. They are not 100% reliable from at least from Minnesota, from specialists I've talked in Minnesota.
Yep.
It works great until that one night you need it to roll down and it doesn't and you get a frost.
Yep.
So it's not, let's just say it's not hands off completely.
Yep.
Um, anyway, so it works really well. It's pretty easy. Oh, okay. So another question. Do you recommend straight knee wall to give more height to the sides?
Okay. So, in hindsight, when the question was asked, would I do anything differently? I should have talked about what this question's getting at, and I think let me zoom in again here. So, what we had is our arches came down to a plate that's welded on here, and that was it. What I would do differently is I would take the next size up in square tubing that would fit onto the bottom of the 1 inch piece of square tubing and raise this up by 3 feet. I don't know if you'd need four, but when we run a tractor through here to prepare the soil, I can't get right tight to each side, and I have to go down with a handheld, or sorry, walk behind tiller to get in right along the edge. Whereas if you had a pony wall that raised it 3 or 4 feet, you would then have more headroom, more height, and that would allow you to get in closer to the edge. The other advantage would be you would have more room when you're trellising crops. We're going to get into next week's webinar is going to be on production. I don't want to get too far into those weeds, but right now when we trellis, say, a cucumber or a tomato, we're limited to 7.5 feet. That's the height of the tunnel. You can take it up there. You could let it grow back down. I mean, but your height is for all intents and purposes limited to it being 7.5 feet. So if you had a 3 foot wall, you could go 10 foot high. You could get more internodes, which are going to give you more fruit and vegetable, which is going to give you more money. So yes, I should have talked about that when I answered that question because definitely that would be one thing. It would add some cost to it, but it would be cost well spent, in my opinion. You could still use the same design where it's sitting on a ledger board. You just, for your 3 or 4 foot piece of tube steel pony wall, that's where the flat iron would be welded to and screwed onto the 2x6, and then the arch would fit into there. So I hope that answers that question.
Yeah, and I think the structural integrity would still be enough. I mean, what we like about an arch design is just because you have more strength overall.
Right. And going to that point, I think it would be important then to be sure that the welds that are going to be done to put a, I'm going to say fastener, that's not the word I want to do, but to let the bottom of the curved arch fit inside the pony wall. You're going to have to weld a piece of tube steel onto that piece because the arch is at an angle and it's not going to fit into a vertical pony wall uh, piece of tube steel that you're using to make the vertical pony wall. So you'll need to weld a piece on there. So for example, I can weld, but I'm not a welder, if that makes sense. Like you would want somebody who welds for a living and will make it strong to do the welding. When we got these arches made, they were out of like we brought the steel in directly from I don't know exactly Hamilton, but down east and had it made at a welding shop and definitely by a excellent welder. Um, I would just advise not having someone who is like me, able to weld, but doesn't do it that well. I would want somebody who really knows what's going on to make sure the joint is going to take the stress. Because Anthony's exactly right. The beauty of this design is its strength, and that would be its weakest point. And I wouldn't want that to fail.
Yeah. Any other questions from people? Do we have one more? Yes. Okay. Well, one more. Why not just make the arches taller, then fool around with a pony wall if you want more height?
Sorry, could you just repeat that?
Make the arches taller rather than fool around with a pony wall if you want more height.
Okay.
So
So,
it'd make it wider, right?
yeah, like you could do that. Again, we did this just easy. The steel from the standard length of tube steel is 24 foot lengths. If you wanted tube steel frame that was, say, 36 feet, just to pick a number. It was 12 feet longer. You could bend it and it would have a higher center, and the edge of the arch wouldn't be as pronounced. You could do that, but you'd have a weld. You'd have to have a joint between two pieces of tube steel somewhere in the arch. I would say if we're going to have a joint, to have a joint at a pony wall is probably better. I'm not an engineer, but if we weld a 10, say a 12-foot piece, or it could be any length, but I'm just picking 12 out of the air, onto the length of each arch, wherever that arch, that weld is going to be the weakest point. I'd rather have that weakest point where it goes into a pony wall, where if needed, if it's determined it's needed, you could put a flat iron brace, like a gusset, on the side of it welded there to reinforce it.
Yeah.
So I hope that answers that question.
Yeah, and actually, I don't see any more. Uh, that's it. Yeah, so thank you. So we'll end it there. That concludes today's webinar. And on behalf of the Horticulture School Organizing Committee, I'd like to thank you for attending today's webinar. Just a reminder, next week's webinar, that's March 18th, is entitled High Tunnel Production and Operation. If you'd like information on how to register, please contact myself or Tom. And I give you Tom's email address is tom.gonsalves, GONSALVES at gov.mb.ca. So again, thank you for your time today, and maybe we'll see some of you next week as well. So thank you.
Yeah, thank you very much.